Hi and welcome to Pre-Calculus. Today's topic is converting an equation written in rectangular form to one written in polar form. So we are used to writing our equations with x and y, meaning they are describing the relationship between x and y. But what if we want to describe our location in terms of r and theta? Well, we have a simple way to go back and forth between these two. We have r squared is x squared plus y squared, and if you want r itself, you take square root. Tangent of theta is y over x. So these formulas are helping us to calculate the radius and the angle. In the opposite direction, when we want to take Cartesian and convert it to polar, we say x is equal to r cosine theta and y is equal to r sine theta. We saw this relationship in the previous two lectures, and here we are going to practice it. The very first question: what's the equation x equal to minus 2 in polar form? You notice that the equation is very simple, and well, it represents a straight line, straight vertical line. This is the x equal to minus 2. What is it we want to do? We want to find out what's the relationship between r and theta of the points. So here is an r, here's a corresponding theta. If you wish, here's another r, here it's theta. We want to see what's the connection between these two. So we know that x is equal to r cosine theta. So we take this and replace it for that. So r cosine theta now is obviously minus 2. Now r therefore is minus 2 over cosine theta. This is asking us what is r equal to, and what is meant there is describe it in terms of theta. So here's a description. Sometimes you have choices. For example, you can write this thing as minus 2 secant theta. Either way, it would be correct. Here's another example. X squared plus y squared minus 2x is equal to 0. Convert it to an equation written in terms of r. Well, we might be curious as to what this thing is to begin with before we even convert it to something else. So the equation is given to us: x squared plus y squared minus 2x is equal to 0. How can I infer the shape of this thing in Cartesian? Those powers sound like I'm dealing with a circle, but where is this circle? Let's write it in the following way. I rearranged my equation. I noticed that this is missing one term from being a complete square, meaning if I put a 1 here, it will be x minus 1 squared. So I put a 1 on both sides. Now I have x minus 1 squared, and this is y squared. I can write this as y minus 0 for a moment. I will explain shortly. And this is 1. I can write it as 1 squared. What's the meaning of all of this? If you remember from your pre-cal 1, x minus h squared plus y minus k squared is equal to r squared was the equation of a circle. It was the equation of a circle where h and k were coordinates of the center of it, and r was the radius of it. So what this equation says, this is looking at the center, which is 1 and 0, and the radius of it is equal to 1. So that's what this shape is. This, if we want to draw it, we go to point 1 as a center, and we draw a circle of radius 1, and circle of radius 1 means this. At any rate, So that was all side remark. It didn't have anything to do with the answer to the question. Uh, Here we can say x squared plus y squared. Simple way to transfer that. This is the whole equation is this. It's a lot easier than anything else to go quickly and convert this thing to just r squared. Remember, we said x squared plus y squared is r squared. So if possible, we might just do that quickly. And then x itself was r cosine theta. So this is an equation in terms of r. No, it so happens that I can factor this thing, r times r minus 2 cosine theta, which tells me either r is equal to 0 or r is equal to 2 cosine theta. Now 2 cosine theta, when theta is pi over 2, is going to become 0, so this point is actually part of this picture. So you might as well just keep r is equal to 2 cosine theta, and it turns out that this equation of the circle that we have here has a very interesting polar description. This one, r is equal to 2 cosine theta, looks a lot easier to solve than that one. Anyway, if you like trig functions, that looks a lot shorter. So r equal to 2 cosine theta is the equation of a circle. Center of it is 1, radius is 1, and it just touches on the y-axis. Okay, so that was interesting. Among many of the trivial questions we had, that one stood out. How about this one? X squared plus y squared minus 4 equal to 0 again. Fastest way to deal with these things, say r squared minus 4 is equal to 0. So you can write it as r equal to 2 or r equal to minus 2. What's r equal to 2? R equal to 2 means for any angle, you go 2 units out and you keep doing that. So here's another angle, again you go 2 units out. So that's obviously a circle of radius 2. Who is r equal to minus 2? Any angle that you have, you draw the angle, and then on this axis you go to minus 2. So that one we were going to 2, this one we are going to minus 2. So as we go up, we are covering the point down here. So I go at the bigger angle, I'm going to come to this point. So again, I'm going to go on a circle, but described in a rather funny way with the use of this minus 2. Both of them are describing the same circle. Both of them are circle of radius 2. We are a lot more accustomed to doing it this way as opposed to the other one, but both of them are correct. How about the equation y is equal to 4? Y is equal to 4. What does that look like? Well, this is from your probably first algebra class. Y equal to 4. You say that is a horizontal line. Can I convert it to polar? Well, we know that y is equal to r sine theta. So therefore r sine theta has to be equal to 4, which says r is 4 over sine theta. You can leave it like that or write it as 4 cosecant of theta, and that will do it. So it's a sort of a culture change from Cartesian to polar. In somewhere in Calculus 2, there is a very interesting section for conic sections in polar. It comes on very handy if you are interested in astronomy, because all the planets go in elliptical orbits around the sun. Well, if you have a comet, it kind of goes on a parabolic path around the sun. If you have something with extreme energy, it's going to go around the sun in a hyperbolic path. And to describe these one of the favorite way of doing it is to do it in polar, and that's how the original scientists who work on our astronomy worked on. So there are some very interesting applications of the polar, but you have to wait a little bit until you get there. Okay, until next time, good luck and God bless.